Good morning, sir. My name is Saurabh Roy. I am from CSE department, currently studying in the seventh semester. And today my topic is about supervised machine learning. Supervised machine learning is a powerful technique used to train computers to learn from data and make predictions. It is like teaching a child to identify different types of animals by showing them pictures and labeling each one. Imagine feeding a computer with a dataset of images of cats and dogs, along with labels indicate which image is which. A machine learning algorithm then analyzes this data and learns identify distinguishing features between cats and dogs. Once trained, it can accurately classify new unseen images as either cat or dog. This process is known as supervised learning. But the algorithm is supervised with labeled data to learn and make predictions. Supervised learning has a wide range of applications in various fields, from image recognition, natural language processing, to fraud detection, and medical diagnosis. Supervised learning is a type of machine learning where an algorithm learns from a labeled dataset consisting of input features and corresponding target values. This dataset acts as a teacher, guiding the algorithm to understand the relationship between the input feature and the desired outputs. The algorithm learns from this labeled data and develops a model that can predict large value for new unseen data. Supervised learning is further divided into two main categories: regression learning and classification. Regression involves the predicting a continuous output value, like predicting the price of a house based on its feature and forecasting the temperature of tomorrow. Classification more focuses on the predicting a categorical output value, like determining whether an email is a spam or not, classifying a customer into different segments based on their purchase history. Common supervised learning algorithms. There are five main algorithms including linear regression, logistic regression, decision tree, random forest, and support vector machines, which are called SVMs. Linear regression is used to predict the continuous values and creating a linear relationship between the input feature and the output variables. Logistic regression, on the other hand, is employed for a binary classification problem where the output is either 0 or 1, such as predicting whether the customer will click on an ad or not. Decision tree. Tree-like structure that partitions the data based on its feature resulting on a decision path for classifying instance. Assembling learning techniques that combines multiple decision tree involves prediction accuracy and reducing overfitting is random forest. And the SVMs are powerful algorithms that find an optimal hyperplane to separate data points into different classes suitable for both classification and regression tasks. First, talking about linear regression, there are four steps in linear regression, which is a fundamental algorithm used to model the relationship between dependent variables and one or more independent variables. Its aim is to find linear equation that best represents the relationship between these variables. The equation is represented as a straight line where the slope and the intersection determines the relationship. For example, we could use linear regression to predict the house price based on the factors like size, location, and the number of bedrooms. The four steps are data preparation, model building, model evaluation, and prediction. Moving on to logistic regression, it is a very powerful statistical technique used for binary classification tasks. where the goal is to predict the probability of an event occurring. It is widely used method in fields such as healthcare, finance, and marketing. Unlike linear regression, which predicts the continuous value, logistic regression predicts the probability of a specific outcome. Typically represents as a value between 0 and 1. This probability is used when to classify data points into two categories based on a threshold value. For instance, we could use logistic regression to predict whether a customer will purchase a product or not based on their demographics, browsing history, and purchase patterns. Decision tree. Decision tree are the type of supervised learning algorithm that use a tree-like structure to represent a series of decisions. They are used for both classification and regression tasks. Each node in the tree represents a feature or attribute, and each branch represents a possible value for that feature. A tree is built by recursive splitting the data based on the feature that best divided into the data of distinct classes. Let's take an example. A decision tree could be used to predict whether a customer will default on a loan based on the factor like income, credit history, and debt to income ratio. The tree would start at the root node representing the initial dataset based on the feature. The data is then split into different branches, each representing a subset of data. This process continues until the leaves of the tree are reached, which represents the final classification or prediction. The root node is the starting point of the tree, representing the initial dataset. Internal nodes are the nodes within the trees that represent the feature used for splitting the data. Branches, connection between nodes representing possible values for a feature. Leaf nodes are the final nodes in the tree representing the predicted output or classification. Random forests are powerful assemble learning techniques that combines multiple decision trees to improve the prediction accuracy and reduce overfitting. Instead of relying on a single decision tree, a random forest creates a multiple trees, each trained on a random subset of data and features. When making a prediction, the random forest combines the prediction from all individual trees using a voting system for classification or averaging on a regression. This assembles approach reduces the impact of noise and bias in the data, leading to more robust and accurate prediction. This has advantages like improved accuracy, reducing overfitting, and robust to noise data. And along with the advantages comes some disadvantages, computational complexity and difficult to interpret. Moving on to the SVMs. SVMs are powerful algorithms that are commonly used for classification and regression tasks. The core idea behind SVMs is to find the optimal hyperplane that separates the data points into different classes as shown in figures. The hyperplane is the decision boundary that maximizes the margin between the classes. Support vectors are the data points that lie closest to the hyperplane, and they play a very crucial role in determining the position of the hyperplane. SVMs are known for the ability to handle high dimensional data and to generalize well to new data. This comes with high accuracy. SVMs are known for their high accuracy, classification, and regression tasks, handling high dimensionality. SVMs can effectively handle data with large number of features, making them suitable for complex problems. And good generalization. SVM tend to generalize well into new data, meaning they can make accurate prediction on data haven't seen before. Evaluation matrix. We can evaluate the learning model on based on the five factors such as accuracy, measures the percentage of correct prediction made by the model. It is simply a widely used metric, but it can be misleading when dealing with imbalanced precision. Make sure that the proportion of positive prediction that were actually correct is useful when minimizing false positive is crucial. Recall measures the proportion of actual positive instances that were correctly identified. It's important when minimizing false negative as priority. F1 score, a harmonic mean of precision and recall, providing a balanced measure on the model's performance. An area under the curve is a measure for the model's ability to distinguish between classes, often used for a binary classification problems. Conclusion on the future trends. Supervised machine learning has revolutionized various industries, offering powerful solutions for a wide range of problems. As we move forward, supervised learning is expected to evolve further, driven by advancements in algorithm, data availability, and computational power. Future trends include deep learning. Particular neural networks are becoming increasingly powerful for tracking complex problems in areas of image recognition and natural language, explainable AI, and federated learning. Thanking you for the opportunity to present me this presentation. Thank you.